Welcome, I'm Mr. B, and this presentation is on your role as a designer with the design process and tools of the trade. Let's dive right in. All right, to start, I want to pose a question. Where do you think a designer fits into this here image? If this image is a company and all these gears and pulleys are people and departments or positions at the company, where do you think designer fits in? So on the left side, you have raw materials, and or it could be the components that you're acquiring to make something. And then on the right side, you have the end user. So that's going to be your end product going out to end user. And if I could just elaborate a little bit more on the raw material side, obviously that's beginning stages of acquiring things. You got deliveries being made, and then potentially some things starting to be produced. So you're going to have some fabricators and possibly welders or assemblers and people like that. On the right side, you might have things like customer service, sales, problem there with my pen, marketing, other people on that kind of end there. So where's the designer fit into this here? We're going to cycle back to this picture here after I'm done presenting some more information about the designer role, and maybe that'll help you kind of figure out where you think they might fit, and the position may vary from company to company, but we'll see a little bit more here. Let's move ahead. Start out mechanical designer job description. We have they design and develop new parts, products, and jigs and fixtures. So in this case here, here's a very fancy rolling bar in this image, and I worked at a company where we did anything you could put on caster wheels. Those are down here in the bottom, the caster wheels. Some are fixed in position, some rotate. You can get in many different sizes, and even what type of rubber or bearings and all that. Tons of different styles, and we made a lot of things that would go on caster wheels. But here, this example, this bar, there was everything in here had to be fabricated the same steel. We outsourced the wood paneling in the front, obviously the granite top. Obviously component purchase there is the soda gun in the center, and then the tanks underneath and everything else used for that soda dispenser. Some of them had beer taps or other stuff. This one actually has a sink over here, maybe for ice. Sometimes you'd have a sink to drain and wash stuff, so you might have a catch basin or a tank on the bottom. But what I want to show is how there's a lot of parts here that had to be made, and actually all this stuff is made in CAD, because you want to make sure that the stuff is going to fit together before you assemble it, before you even make the parts, because you don't want to be wasting time and money making parts that are off half an inch or maybe even a quarter inch. They're not going to fit properly. So CAD is really important here, and that's where a designer is doing a lot of work before a lot of that manufacture actually even happens. Moving ahead here a little bit, we also see designers do things like revise existing products and drawings. In the same case of this here custom bar, we sometimes made this bar half the length, or maybe you had two sinks in there, or it could be a little bit lower so that it was more ADA compliant. That's American Disabilities Association. So for people that maybe had a disability, you might make a countertop lower in a scenario if it was meant for a space like that. So there was a way to customize this stuff. Customers could order that, and that's where the designer can take an existing one and redesign it in CAD, and once again make sure that it's going to all fit together before parts are made at the company or ordered, like the wood paneling or other pieces. Okay. Also, I have here written ECR ECO. That's engineering change request or change order. So with that, that might be if you are making the same thing over and over and you have a factory line, and if your people on the factory line or somewhere, if they see there's a problem with a part, they might put in a change request order so that can be fixed, because you don't want to have all these problems going on. So it can send back to the engineering department, and then you as designer may have to make an adjustment, and then it may be put onto a drawing, a new revised drawing that goes back out into the shop, where they start making the part with the correct dimensions or whatever it may be that had to be changed. And so you may be involved in that part. You may be involved in providing installation and construction support along with BOMs, that's bill of materials. So in this case, the bill of materials, you're working with the suppliers to get raw material and or component parts. So you're working on that side of the company, and then you are also putting together drawings for construction assembly. Let's say this here rolling bar, when I worked there, it might have been 20-30 pages of construction drawings so that the assemblers can get it all put together properly. Or it could be something that it's going out into the field for service techs, that they understand how the thing works, that they can take it apart and put it back together. And that could be something more elaborate, let's say a generator or automobile or something else like that, that they need to see some drawings because they don't work at your company, but they do the service on it out in the field. So you're doing drawings like that in addition to the original drawings for making the parts and components. So you're making lots of different important pieces that will help many different departments for the company. Lastly, we have provide dimensional drawings and photorealistic renderings to marketing sales. So for that end user, you want to help marketing sales sell your products. If they can't sell your products, your company's not going to be able to be making anything because there's nothing to sell. So sometimes your company is going to be asking you to make renderings or provide drawings for sales and marketing. That way they can get it out to promote it, or maybe to get a sale out of it. And so you're assisting them in that way. So you can see here from these 4 different ones here that you're already placed in quite a lot of different positions potentially at a company, and you're assisting a lot of different departments, right? Well, so tools of the trade, really important. Obviously CAD, solid modeling software. There's a lot of different software companies out there with really good CAD. Typically you're going to get the best CAD if you're buying a paid one that you had to pay for subscription. You get the best features, updates, all those things. But there's a lot of options out there, and depending where you work, they may choose to go down the road of looking for free or low-cost ones, or not pay for subscriptions. But I suggest, if you can, try to get the updates year to year, because whichever one you do use, they will keep on continuing to advance their software. And as you can see here in CAD, you can make anything you want, anything in the world. This is just an image of someone that put together a funny looking little airplane, looks like a toy, using a whole bunch of nuts and bolts and a spark plug. And so it looks great here in CAD. To actually build in real life might be a challenge, but it kind of just shows that in CAD you can take it to a lot of different extremes. Obviously you can use it to make a whole car if you want, an airplane, a real airplane, spaceships, anything you can think of, anything you can dream of, you can do in CAD, and it's such a wonderful tool. On top of that, a designer is going to be doing a lot of measuring. Whether you're measuring physical items that you may want to then model up into your drawings, like in this case, someone might have used a caliper to draw up spark plugs and nuts and bolts so that they could then make their airplane here. Or in some cases, you can get those CAD files from the companies that actually make the nuts and bolts and spark plugs. But either way, there are many times where you're going to actually have to do physical measuring, and that way you can get it as accurate as possible in your CAD drawings so that you know when you produce the thing in real life, it's going to all fit together. talk about the design process. And this process can go back and forth quite a bit. I'm just going to lead it down a road here. It starts out with constraints and criteria for success. Constraints may be some limitations or maybe limits on what you have available for material or other factors, how much money you want to spend. Criteria for success, what do you want it to do in the end? And keep it within the budget or things like that. So there's a lot of things you could start out with here. And you're going to do some brainstorming. This is really fun if you have multiple people that you're working with. Teamwork is always the best way to do things if possible. You guys do some research. You want to do some research because, hey, there's many times you may find that there's already something out there like that. Whatever you're trying to design, there already may be a product out there, or you may find something similar and then all you have to do is just modify it. You're going to then probably start doing some drawing in solid model CAD software, like I've been showing you. It's very, very powerful. If you use it right, you can do all your design work to make sure you satisfy everything you want before you even produce the product, and then you can make already pictures and renderings to give to marketing to try to get sales done before you start even producing your product. And you're going to probably try to prototype something. In this case here, I found a image of a bulldozer, or I mean a backhoe and a jackhammer, and I've actually seen something like that driving along the highway in road construction conditions where there's somebody sitting in a machine and they got a jackhammer in the front, right? So somebody was sick of holding that jackhammer and thought, you know, if I could just sit in a machine and it'd be a little bit easier on my body, and then I could get more work done, right? Be more efficient. So they probably went down this process to build one, right? So you're going to analyze things, see if all the things you want checked off from your criteria and constraints over here. And then if it's looking good, you start mass producing it, right? If it's not, you may want to go back to the prototype stage. Or with that, do some new drawings, maybe do some new research, new brainstorming. This thing can go around and around and around, right? Because lastly, you're going to want to seek possibly how you can make new iterations and continue to advance it. So even when you have it out mass produced and out to the public or whoever your customer is, you're probably going to start seeing, hey, I could have done this or that better, and even whether it be for the end user or for your own company to make it more efficiently and save money, which results in just better things for the whole overall aspect of it, right? Now we're back to that picture from the beginning. Remember we talked about raw materials to start, end user and end product. And I think I talked about people on this side near raw materials and people on the end user side. And at the same time, there's stuff going on in the middle here, right? A lot of decisions being made. So where do you think a designer fits into this? Boy, at any moment, could be on any side, left or right, top or bottom, but probably in the middle, probably useful for the entire company. And that's going to make it a really fun job to be in, right? Because when you're in demand and people need your help, need your expertise, that's where it just makes it, in my experience, it made it really fun to be a designer. So I hope this helped you understand what a designer does, your role as a designer, the design process and tools of the trade. If you have any questions, leave them in the comments. And if you like my content, please like and subscribe. Thank you.